Go, no go. All right. We did it. Thanks, Pamela. Thanks for putting us live. Again.
Here it is.
Is it?
We're all in our boxes.
Are we? I'm not seeing it.
You gotta bigify it, I think.
It's just the delay on the YouTube.
Got it.
Okay. And how's Ashley doing? Yep, she's back.
I'm here.
Yay!
Right.
I'm here. I've been here the whole time. So I'm like, if y'all see me go black or whatever, I mean, yeah. I'm here.
Well, if I just see you, like, as long as you're moving, then I won't, fill in for you. But as soon as you just like stop and freeze on the screen, then I'll know it. And that'll know to like shift and go like, Dave, what do you think about this news that Ashley brought up that you have no idea about? What's your opinion?
Right.
That pays to keep paying attention.
Yeah, exactly. Dave and Pam, just be ready for me to shift the attention to you as Ashley's internet just holds.
Just say random shit.
Yeah, and Ashley, whatever you're doing, if you're having to like hold two wires together with like whatever it is, just you're having to like
send us a signal.
Yeah.
A signal.
Yeah, exactly. Yeah. Keep the signal going. Awesome. How's everyone enjoying their new year? Their new quarantine. But But this is it. This is it. This is the last. This is it. We're done. We're finished.
That's what they said.
I know every time. This is 4, 5. Yeah.
Well,
Yeah.
we still need the Omega variant because that just sounds like a movie.
Right. Well, and unfortunately, we haven't got the boosters here in Canada yet for the younger people, and I include me. And so we're still got like that one step before we can feel a little more protected.
Oh.
Yeah. You're all boosted. I know.
Yeah,
I'm going next week, so therefore, because the last couple times I've been sick, so I'm like, look, this flu and this booster, I'm getting both because I don't want to be coughing for another 2 months like I was before.
Yeah.
And Dave over there scaring us, talking about this Omega variant. That's still like the end of the world. What you trying to do? You trying to put the end of the world on us? You trying to kill us?
4 or 5 Greek letters down. Still.
See, here's the thing, Ashley. There's still more letters in the Greek alphabet.
We need an Omega.
That's how this works. As long as there's Greek letters, as long as there's letters in the Greek alphabet, this could just keep going.
Yeah. What do they do after that? Anything?
Well, let's just hope they don't switch to the Chinese alphabet.
Okay.
That's like 4,000 characters. So.
There you go. That'll keep us busy for a while.
Yeah, exactly. All right. Well, let's get started. I think everyone's here. I can see everyone watching. I can tell that everybody is focused and ready. This is it. This is our moment. All right. Oh, wait. Now you've all got the giggles. I'll wait. Okay. Hello and welcome to the Weekly Space Hangout for Wednesday, January 12th, 2022. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about, James Webb again. An interstellar probe proposal. Everything to see in the night sky in the next month or so. Diamond rain on the ice giants and a strange mystery at Jupiter solved. Joining me this week, we've got on my screen to my right, Ashley Walker. Ashley, welcome back.
Hello. Thank you.
And just to warn everybody, Ashley's internet is not great, so we may lose her. She may be stalled on the screen. We may be working around it, but so far the signal is holding strong. We've got Dave Dickinson. Dave.
Hey, I've actually got all telescopes on deck here tonight. I figured I'd set them all up. So.
Perfect.
This is everything I own or I currently own or have loaned to me right now.
That's fantastic.
He's showing off.
Yeah, he really is. Yeah. Look how he's placed on the screen a little to the side so that all those telescopes can have equal screen with him.
I have my books on the other side too. So.
Yeah, okay. All right. And we got Pam Hoffman. Hey, Pam.
Hey, Fraser. Nice to be back. Kind of sooner than I thought. I was swapped with someone.
Right. Yeah. And no telescopes, but just like all the things to see. So I guess you've got the targets. Dave's got the telescopes. All right. So before we get into this week's special guest, and I promise you this is a very special guest, this is going to be a lot of fun. We need to give a huge shout out to our good friends at the Weekly Space Hangout crew. They're our friends, our fans, our executive producers. They call the shots. We do what they say. So if you want ultimate executive power over me and the rest of the co-hosts, go to wshcrew.space. They will hook you up and give you all the power to bring in awesome guests. And speaking of guests, we've got Scott Bellamy from NASA. Scott, welcome to the Weekly Space Hangout.
Oh, good evening, everybody. I'm glad, greatly appreciate you extending the invitation to me.
It looks like you've got an extra doctor, but I'm assuming that typo will be removed in a second here. So the question I always ask people, who are you? What do you do?
Well, I am currently a mission manager in the Planetary Missions Program Office at Marshall Space Flight Center. We tend to all of the outer planet and asteroid missions with the exception of Mars. So if it's going somewhere or doing something, it's probably ours.
Right. And then give us an example of a mission that has just recently launched that would fall under this list of missions.
Well, coincidentally, the subject that we might be talking about later is DART, the Double Asteroid Redirection Test.
Fantastic.
Yeah.
I mean, we've talked about DART in the past, talked about its launch, but now it's out in space. Can you give people just a quick overview of the mission and what it's going to be doing?
Oh, yeah. I think I have a chart that shows kind of an overview of the mission concept that if you can pull that up, that'd probably be easiest to help explain this.
Although we do have podcast listeners, so you're also going to have to explain
so
it
I'll talk through it
with just a wall of words.
Sorry to torture everybody with words. So DART is going to fly to the Didymos binary system. It is an asteroid that's not Earth crossing, so it is not a potentially hazardous asteroid. This one is very unique in that Didymos, the primary, which was found in 1996, was later discovered to have a small moonlet, which has recently been named Dimorphos. The intent of DART is to demonstrate kinetic impact deflection of an incoming asteroid. And so what we're going to do is fly DART and intentionally impact with Dimorphos in the 26th September of this year. And our desire is to slow the asteroid down in its orbit by approximately 10 minutes. If we can achieve anything over 73 seconds, the telescopes here on Earth will be able to record that. And anything larger is just proof of concept. Right now, they're estimating that given DART's mass, that it should be able to slow it down by 10 minutes.
And so when you say 10 minutes, like the orbital period for the moon to go around Didymos is, you're going to knock 10 minutes off that orbital period.
Right. Right now, it's just under 12 hours for Dimorphos to orbit Didymos. And so we hope to knock that down to, 11 hours and 40 something minutes.
Right. So, I mean, why? What did this moon ever do to us?
Presented a great opportunity. It's near enough to Earth that we can easily observe it with the Earth-based radio telescopes and to some extent optical telescopes, but it passes close enough that we will be able to observe any change in the orbital period as it moves across the face of Didymos. The telescopes here on Earth can easily detect if there has been a change in its orbit. And in terms of what are some of the most hazardous asteroids we worry about, Dimorphos is not quite 400 meters. It's slightly less than that. But in terms of size, it is one of the believed to be most common sizes of asteroids that could potentially impact Earth.
And you were the mission manager for OSIRIS-REx as well, and I'm sure you've seen some of the other the asteroids, say Ryugu and so on, and they are these piles, these jumbled up piles of rock that that our poor volunteers had to count at one point. So what do you think how would that, like, if it is a pile of crumbled up rock, what would that look like, do you think, as opposed to a solid rock?
Well, even with Bennu, even though on the surface it looks like a rubble pile on the surface, we don't know the complete morphology of Bennu itself, so we don't know how much solid is on the inside. But even still, Didymos is 780 meters. It's a fairly large asteroid, and Dimorphos itself is 163 meters. So Dimorphos is, it's on the order of 3,000 foot in diameter, so it's slightly over a half mile wide, and even a body, that's a rubble pile entering as a single object at a half mile in diameter would, not be a happy day for somewhere. How it would behave during re-entry during entry is a question that I don't have the basis to answer.
Now, you are a mission manager, and you've been the mission manager for several spacecraft. So what does that job entail?
We act on behalf of NASA headquarters. So headquarters gives us, headquarters, in some cases, they select, these missions, these spacecraft to be developed. And we shepherd the projects through the development all the way to end of mission. So we watch after every one of these from beginning to end. Favorite term is cradle to grave. So we watch what's going on. We look for challenges they may be facing. We act as not only the champion for the mission, but also the watchdog, for short of a better term.
And so, you've been mission manager for a bunch of them, but one of the other big missions that you're going to be responsible for is the Europa Clipper.
Oh yeah.
So I guess have we already reached the cradle stage of Europa Clipper?
Well, definitely, because it's in development. We're growing it right now. It's the pieces of it are coming together. And October of 2024, we hope to be on a very large rocket heading out towards a slightly complicated flyby. We're going to do a Mars-Earth gravity assist to get out to Jupiter. It's not going to be a direct ascent or a direct trajectory.
Have you got a final decision on the launcher for Europa Clipper?
Oh, we do. It's already been announced that it's a Falcon 9 Heavy.
Oh, wow.
So we know that we're going to be launching on a Falcon 9. And so we'll fly out to Jupiter and conduct surveys of the icy world moon, Europa. We have compelling evidence that Europa has a liquid ocean underneath the ice shell. We'll take measurements of the thickness of the ice shell, look at the constituency of, if we encounter plumes, we'll analyze the contents of the plumes. We have a dust analyzer that will look at the dust that we can detect in the vicinity of Europa and try to find compelling evidence of conditions that would be favorable for microbial life in the oceans, and hopefully set the stage for a future lander mission.
That would be amazing I can't even imagine what a lander mission would be like going down to Europa. What kind of resolution will you be able to capture of the surface?
Now we got to play Stump the Chump, because I can't remember the resolution of the images.
I can Google it if you like, but I'm just sort of thinking, there are these features they're suspecting that the surface of Europa is covered by these penitentes, these awful jagged spikes that we see sometimes here on Earth, and I just wonder, will we be able to spot those? They're shadows or something.
Well, I say we definitely yes on that. I mean, our intent is to build at least an 80% comprehensive world map of Europa to be able to help select the lander site. Probably one of the most sorry, getting tongue-tied. Most important things to try to capture will be the ice shell thickness.
Yeah.
Since the lander would have to be able to penetrate. And there is actually a lander pre-project at JPL that's been going for a few years now. We're still waiting for Congress to, approve the full budget and actually put us in a position so that we can begin, the actual project in earnest. But, the team at JPL for lander has been doing a lot of work, whether it be Europa or another icy moon. They're doing some really great groundbreaking activity, and we're developing the lander technologies that we need, regardless of which one it is. But either way, they'd still have to be able to penetrate the ice shell, so we need to know how thick it is.
Yeah, and we've covered like on Universe Today and other places a lot of the sort of out there ideas to try to get down and actually sample the water underneath the ice shell. But the hope is that there are geysers that are actually throwing this material right into space. So
Yeah.
is the possibility to sample the stuff for Clipper to essentially stick its tongue out and taste the geyser as it's flying past?
Well, that is actually planned. We have the instruments on board to be able to do the mass spectrometry on the geyser plume. The biggest, and we actually have the past observations that show us that probably better than 90% likelihood that we are seeing geysers. And the desire is to fly through, or as near through a plume as we can with a mass spectrometer and sample the contents.
So how are the challenges different for planning and running a mission that is going to be close to Earth, closer to the inner solar system, to one that's going to some of the, starting to go into the outer solar system? How does that change your process?
It depends on, as a spacecraft, it would have been nice if Clipper could have been a nuclear spacecraft, for example. Right now it has very large solar arrays that have to be deployed. Interestingly, though, DART also has very large solar arrays, even though it's not going to the the outer solar system. And DART, with its rollout solar arrays, are very flexible, and so that's presenting some challenges in that they're floppy. You can't
Right.
see my hands.
That's going to be trickier closer into Jupiter, isn't it, with radiation and stuff for solar panels?
The radiation is with Jupiter is the largest problem with that spacecraft, because fortunately Juno is out there right now, and so
it has a wider orbit.
It has a wider orbit, but it's collecting some radiation environment data that is going to be very helpful for Clipper. And but all of the critical electronics for both spacecraft have to be enclosed in a vault to protect them from radiation. But then you still have to worry about the exposed part of your instruments on the outside of the vault, and how much life are you going to be able to achieve. Something that you're hoping is going to last 5 years. It's being bombarded routinely every time you pass through too near to Jupiter. You're trying to fry yourself.
And that radiation environment was one of the decisions to give it a much more interesting orbit than just like going into orbit around Europa and bathing in that radiation day in, day out, right?
Exactly. Survivability was why they've they call each trip through a tour, and so they have roughly 50 tours that are planned, and each pass gives them a fraction of Europa's surface as visible to the instruments. And for most of the passes, everything has to be working at the same time. OSIRIS-REx, we had the option on that one to only have some of the instruments operating at one given time, depending on what we wanted to do. And OSIRIS-REx could remain in the vicinity of Bennu for as long as we wanted in some cases. But for Europa Clipper, it's everything on for each pass. So you're taking all your data at the same time. So that challenges some of your design for your data system. Their bulk data storage on Europa Clipper has to be very large and very robust, because you've got everything going at the same time.
you're gathering all that data in a moment, and then you're having to store it up and then trickle it back home when you have time.
Yes.
Right.
Once you get back out of the, you go into the fire and then you come back out and then you send your data home.
Right. So Nancy Graziano asks, if Scott could pick any new mission for NASA to do, cost is no issue, what would you choose and why? So what's on your bucket list?
Huh. That's a good question. Actually. I threw out, Neptune a little bit earlier because it doesn't seem like we have any interest in, we don't have any missions going to Neptune. It seems like ever. I mean, Saturn's cool. We've been there a few times. Mars is great. We've been there a ton of times. I'd actually like to see a mission to Neptune, and
Yep.
and an orbital, and maybe even an orbital mission to Pluto. But Pluto gives us a challenge, and it's so far out, and that was the problem with New Horizons. You could only do a flyby because you had to get there. And you're there at such a high velocity that you can't just slow down.
Yeah.
It would actually be nice if we could have an orbital mission at Pluto and Neptune.
And sort of following on that, I mean, you talked about the idea that there's a lander planned for Europa. Is there a kind of mission that you would like to see? Like, is there I'm trying to think of a way to describe this, but like, are you like landers, rovers, orbiters, impactors? Is there a type of machine that you would like to send out into space? If that question makes any sense.
It does. I just, my wife ran the Disney Marathon on Sunday, so we didn't get back until late Monday night, and I'm still tracking. Even though she ran the marathon, I'm tracking.
You get to run the marathon as well. But I totally I guess I'm really fascinated by some of the really unique and interesting ideas when there's a really interesting target location, and that brings up very interesting ideas, engineering solutions to be able to explore that. I mean, you think about. Go ahead.
Oh, I was going to say, I think that the one I've always, kind of fantasized the most about is a descent vehicle into Jupiter.
Yeah. That would be amazing. Yeah. Because you could fly like a plane in the atmosphere of Jupiter for a while, right?
Uh-huh.
Yeah.
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 But the problem with, Jupiter, like, going down into the ocean is, you reach, crush depth. And, the challenge of being able to descend far enough into Jupiter to see what kind of surface it has. That would be actually really interesting. To me, just what is down there? What's underneath all of that?
Yeah, I mean, the closest we got was when Shoemaker Levy 9 smashed into it and threw a bunch of its guts out onto the surface. But
it was Galileo. It had a descent probe.
Galileo had a descent probe, and then Galileo became the descent probe.
Yeah.
and in both cases, like, they didn't make it far.
No. And so that's probably one of the my pipe dream kind of mission would be to have a descent vehicle that could actually significantly penetrate Jupiter.
Yeah, it's interesting. Like, I think Randall Munro from XKCD, he did the math that you could fly an airplane in the atmosphere of Jupiter poorly, Saturn for a long time, and then Uranus and Neptune quite well. Of course, the wind speeds are ludicrous on all these places, but still, that there is real science to be done, that you could hang out in the cloud tops and then descend in and then eventually get smashed by the pressure. I love it. I think that's a fantastic idea, and it's got my vote. Scott, thank you so much for joining us today. If people want to follow your work, where should they go?
Honestly, go to the mission pages themselves. PMPO has an external where we track all the missions. But the best thing is just to go to nasa.gov. Since OSIRIS-REx launched, I think I've been very sloppy about maintaining my Twitter account. I don't think I've put out anything since then.
That's best. I'd much rather you focus on spacecraft than getting into pointless arguments with people on social media.
Oh, definitely.
Yeah. All right. Well, Scott, thank you so much for taking the time to chat with us today. Good luck with both DART and Europa Clipper and bringing OSIRIS-REx safely home and all the other missions that you're going to be working on in the future. And thanks for joining us.
Thank you so much. Thank you for having me.
All right, let's move on to the space news portion of the week. Ashley, you seem to be moving on my screen, so I'm going to assume that that your internet is holding.
I am here.
Let's talk about Diamond Rain.
Yes, like the song Rihanna says, "Shine bright like a diamond," right? In rain. So one thing that I really found really cool and fascinating is I am the planetary ice queen, so I just want everyone to know that. Well, the princess, because then I'm becoming the queen. But anywho, with that being said, right, one thing that I found very, very fascinating is that, obviously this has been theorized for quite some time. So as we know, it has, as we know, most ice giants have ammonia, methane, so on and so forth. And these are, ice giants, so they're farther out, which means they get a harder, it's very cold, as we know. But within the inside of the core, within the core, obviously, it's rocky, it's hotter, and obviously will go away. It's colder, as I just said. And so they did a lot of laboratory work on this, which was featured back in 2017. Mm-hmm. Which gave them the formation of the diamonds. And so what they were looking at was more so of how they had methane, which dissolved into hydrocarbons. So shot out into hydrocarbons after the rocky core within the mantle, which is shot out like a jet. So then once it did that, it crystallized into diamonds.
So hold on. So you've got these like almost jets coming from deeper down inside the atmosphere of at a deeper level inside, kind of squirting up these hydrocarbons, and then they are sort of crystallizing into diamonds.
Wow.
Correct.
And then that's raining back down.
Yep. And it's raining back down, and then it does it all over again. So the cycle does it all over again. So now I'm pretty sure my advisor's watching by now. So please don't ask me any questions tomorrow in group meeting.
I'll ask the questions, and then your advisor can know that you were properly interrogated about this. Yeah.
Exactly.
Yeah. So what's the update then? Because as you said, this had been theorized back since 2017, and I remember the story coming out, and we were all pretty fascinated. What's the new news?
So when they did the model, it actually obviously came about to what they figured, and so because they were doing new developments and laboratory work, but the only thing is that, of course, as Scott said, as we all said, there is no mission to icy bodies and ice giants. There's no mission, and we should have a mission. NASA, I think I should run it, but thank you.
Well, there was a plan. There was a plan. There was the Triton mission, right? So there was the 4 latest Discovery class missions: the Da Vinci Plus, the Veritas, a mission to Io, and the Triton mission, which would have gone to Trident. Sorry, that would have gone to Neptune's moon Triton, and the 2 Venus missions were chosen, and Io and Trident were left to wait until next time.
Yeah, it didn't make the last decadal survey, but they've been talking about doing a Uranus Neptune orbiter like for the 2040 timeframe.
So what would it take then to figure out whether or not this is true?
Well, As in most, well, obviously we start off with laboratory studies and then we go off into, observational. And because they're still doing some things laboratory and computational, which is what's helping them right now. So, like, if we can get a bigger push of people who are asking for this, it can happen. I mean, I definitely think it can happen. So.
Oh, for sure. No, I mean, I think, I find that I don't go an episode without whining that we don't have a mission to Neptune. So I think, we're all doing our part. But I'm more asking, like, what would a mission, like, what kind of observational evidence? Like, if you could be out there at Neptune with whatever suite of instruments you wanted, what would you be looking for, do you think?
Well, mostly we'll be looking at, as like everybody else, water, right? We're looking at because we're looking at ISIS, which can help us understand the better habitability of these two ice giants. Right. And so while we're looking for these diamonds, because they're shooting out, but they're actually inside, right? Which makes it a little bit harder because in 1977 when Voyager 2, like what we seen the outside, but we did not see the inside.
Yeah, 89.
That's part of the problem.
Yeah, it was 86 for Uranus and 89 for Neptune. But I wonder, like, are these diamonds getting kicked up high enough into the atmosphere that maybe there'd be some kind of presence, like we could somehow detect their existence, or do we have to send Scott's airplane into or submarine airplane to find them?
Right, and that's definitely what I'm thinking as well, because of the way that the article had read about the atmosphere in itself, and also how cold it was as well, and that's something too that we got to look out for. Yeah. So here's the obligatory, come on, NASA, a mission to Neptune, please. Request. Awesome. Thanks, Ashley. All right, Dave, give us the James Webb update.
Yes, James Webb did a thing, and we all wrote articles about it. It's like James Webb is now fully deployed.
It's done a lot of things.
Yes, it's the big thing that happened that kind of marked this past weekend, the end of the deployment phase. Is you can see in the photo, there's two wings on the James Webb had to be folded up because it had to fit in the Ariane 5 fairing. Mm-hmm. So it has to kind of unfold origami-like once it's in space. And of course, we talked about last week how engineers have to understand they never were able to unfold it in a vacuum on Earth because there's no vacuum chamber big enough. They never unfolded it in 0G, never unfolded it in a vacuum chamber. So they're learning how all these things behave as they get unfolded, and they're reacting accordingly. That's why you see some things in the timeline where they're like, oh, we're going to give that motor heated up a little more than we thought, so we're going to give it a little more time to cool down, or they speed up the timeline. So that's why there's a little bit of flex time built in there. But what happened last weekend is those two side panels folded into place and latched into place. The secondary mirror is already down in place before that. The sun shield is tensioned, and we now have a fully unfolded telescope. So what they're doing now is over the next 10-day phase is they've got to take, and those mirrors are in their stowed launch position. They have to be folded out, so individually into their orientation position. And we should be going into L2. It's T plus 29 days. That's right around January 22nd, 23rd. It launched on Christmas Day. That's probably going to be the next big event, is when it actually goes into that Lissajous halo orbit around the L2 anti-sunward point about 1 million miles out. And once it reaches there and gets into its new home.
And we also got some really excellent news about the initial launch and the amount of propellant that it has on board.
Yes. Yeah, actually, they did the initial course corrections in the launch for the Ariane 5. Of course, this is a joint mission. I always like to tell people this is a Canadian European Space Agency and NASA mission, which doesn't always come out in the news. A lot of people just say, well, it's NASA. It's actually a joint international mission. And the Ariane 5 launch on the from the Kourou Space Center in French Guiana was so accurate that they found that they didn't quite need as much fuel as anticipated to get into L2. So that means that not only will they make their 10-year, because it has to adjust periodically, it's not a stable orbit at L2. So its 5-year primary mission and its 10-year extended mission should be good, and it might actually have some fuel to go a little longer if it's in good shape.
Yeah, I've heard 20 years.
Yeah.
Amazing.
Yeah, it's so exciting. I know. It's like
The only thing that worries me, when they're doing spacewalks on the ISS and you see all the little micrometeorite debris strikes that they get on the outside of the space station, James Webb's just sitting out there naked. And you think about all the little dust particles and things we don't know about flying around out there.
Yeah. Well, and NASA even said that some kind of impact with James Webb is almost inevitable.
Yeah. That may be graded over time.
You got to imagine there's all kinds of stuff collected up at L2. I mean, if you ever drive around and see those little kind of corners that don't have people driving it, there's all kinds of stuff there just sitting there.
Yeah.
But I see all these, you see the results on the space shuttle, and when it was flying and on the ISS, they get these little tiny micrometeoroid strikes. Some of it is from low Earth orbit space debris, which James Webb doesn't have to contend with. But a lot of it is just from natural dust and micrometeoroids and stuff.
So it's not just seeing the beginning of the universe, not just seeing exoplanets, but James Webb will be able to do some observations here in the solar system. Ashley, is there anything you'd like to see imaged by James Webb?
I don't know if it would be able to find.
I want to see the exoplanets.
Yeah.
I want to see everything. I want to see the protoplanetary disks. I want to see it all.
Yeah. It's a pretty wide field of view. I was doing a little research into that. It's 3 degrees, which is vastly bigger, and so people are I think are going to be a little surprised that it doesn't have the resolution, doesn't have the fine grained resolution that Hubble does with
6 times a full moon. Yeah, so that's pretty big.
Yeah. So it's really big, but what it is it's very sensitive, and so it's going to reveal very faint objects that are in that.
I'm really excited to target some of these, like the TRAPPIST-1 system, to target all these exoplanetary systems and start getting the spectroscopic analysis of if there's anything, water vapor, carbon dioxide, anything going on interesting there.
Yeah, I think a lot of people are on that. They want to see the other planets,
But even in the solar system, like I'm envisioning, like it could turn on Jupiter and see storms and large scale structures unfolding in very quick time. It can be brought to bear on Kuiper Belt objects and asteroids that are in the outer solar system. So
those aren't too close. I mean, you think of glasses.
No,
I don't know.
No, as long as it's like a few hundred meters away from James Webb, it can probably focus on it.
Remember, we had Hubble on hand just in time and repaired for the impact of Shoemaker-Levy 9 in '95.
Oh, right.
So
that's right.
If something like that comes up, James Webb could be on hand to witness it.
I guess they've got a year planned out of what it's going to be looking at right now, right?
Oh yeah.
The first year of it?
It's about 6 months of commissioning. I mean, we'll probably all write an article when we get our first blurry starlight image from it, but they got to calibrate them.
Well, they've actually begun the call for the second year.
Yes.
Oh.
So people are now on deadline to put together their proposals for the second year of observing on Webb, which they don't even know what's going to happen with the first year. So.
Can James Webb stop doing things on Saturday? That's what we were talking about. It seems like every it launched on Christmas Day on Saturday, and
that's right.
The unfolding happened. The formal announcement and everything happened on. It seems like a thing that all the press releases are dropping on Saturday.
Pamela is just putting in the chat that she absolutely agrees with you. Yeah, I think it really has thrown off our entire schedule. I don't think anyone realized that spacecraft launching on a Saturday and on every Christmas major morning. Event it's on some kind of 7-day cycle, and so now nobody gets a break.
Yeah.
They should just put it back one day. You know what? Just one of those events, they just waited one extra day, two extra days, start on a Monday. That would have been better.
Actually, its entry into L2 probably will be 22nd, 23rd. That's a weekend.
That's a weekend.
Yeah.
Yeah.
Now, we all know astronomers cannot wait. We can't hold nothing. We can't hold water. So For we're gonna be sitting there like, oh my god, I gotta tell y'all what happened. Oh my god, let me tell y'all. That ain't even gonna work.
When they nudged the launch back, because originally it was on the 22nd, I saw all of space Twitter all at once. It's like they're launching on Christmas morning. How can that even happen?
Sure
they were like crossing their finger. We were like crossing our fingers and crying at the same time. So like I was really scared and I was happy when and I was screaming because you would have thought I got proposed to on Christmas the way I was screaming, but no, it didn't happen.
I couldn't believe that it just launched. Like it just like after all the delays and all the issues and all the jokes, ha ha ha. Webb's never going to launch. But then on Christmas Day, boom! It just launched.
Launch
first
articles,
time.
Unless something happens extraordinary, launch articles are pretty easy to write. So you can have it about 90% written. Because you figure it's either going to launch, delay, or have a problem. So there's 3 options for a rewrite on a launch article, basically.
Yeah, it's true. It's true. All right. Well, I'm sure we'll be talking about James Webb again next week. Pam, what is in the sky?
Actually, it's kind of quiet for the next 30 days.
Back to Ashley then. No.
I do have some highlights. And I like to talk about things you can do. We'll get to that in a second. I kind of have an overview first. Comet Leonard is still in the southern hemisphere. We have to wait for meteor showers till April. There's 2 contests. That happens to be one of them. And the Globe at Night has a new project opening. There are 12 conjunctions. Only 3 of them are kind of notable. But we go through kind of the list. January 17th is the full wolf moon. As you know, they each get kind of 1 or more names. And we're kind of quiet until the very end of January. The 2 contests are, and we got the slide for that one, design moon digging robots. This is a Lunabotics Junior contest from NASA. They're seeking young engineers to help design a new robot for excavation. And this is for K through 12 students in the United States. The rest of the world, for public, private, and they're accepting entries until January 25th. So hurry up if you haven't done it yet. And this is a collaboration between NASA, future engineers, and they asked the students to design a robot that digs and moves lunar soil called regolith. And if you aren't a young person, you can enter to be a judge of this. The winner is going to be announced on March 29th. And then we go over to nominate a student with perseverance. That's in its 2nd phase. That opens February 1st and it goes to the 28th. This is 6th graders through 8th graders. Again, U.S. public, sorry, folks. If you're public, private school, homeschool, that kind of thing. And there's 4 rounds total. And they just want to recognize young people who have been particularly, perseverant. They persevere with their studies and so forth. They got cool awards. They get a special message from NASA's Perseverance rover on Mars. And they get a chat with the rover team, as well as an award pack of printed materials. The Globe at Night project is opening January 24th. These go for 10 days, and they want you to look at Orion, whether you're in the southern hemisphere or the northern hemisphere. And I really found a wonderful summation of this over at the International Dark Sky Association. They say every year the Globe at Night raises awareness about the impact of light pollution by inviting community scientists to measure and submit night sky brightness observations. I tried this last month, and of course, out here where it's always beautiful and clear, nope, clouds, rain, cold. I'm going to try again, though. On January 25th is the last quarter moon. And like I said, we have some significant conjunctions. I think things like Mars, they're kind of dim right now, right? So, I don't know if we're going to see that, but that's January 29th, Mars, Venus, the moon, they're kind of all together. But the Venus and the moon will be the big things to look for. The 30th, of course, the moon's going to be close to the new moon. So you'll see Venus definitely. It's freaking bright. It's going to be so bright soon. The 30th of Mercury and the moon are in conjunction. And kind of everything's going to shift into the mornings. We've had a lot of really nice stuff in the evening. Nope, it's going to be just in the evenings now. February 1st is a new moon, and the 2nd, Jupiter and the moon. Of course, it's a 2-day-old moon, so it's going to be very, very thin crescent, but this is kind of fun. You can see it in the west very early in the morning. I actually go and try and look for these planets when it's still light out, see how early on I can see them. You can actually see planets before it gets dark. That's kind of fun. Then we got the 1st quarter moon on February the 8th. And then we're February 16th, full snow moon, and Mercury is at its greatest western elongation. Again, they're all going to be in the morning.
So Mercury, take your word for that.
Yeah, I know. I'm so sorry. There is something else of note in February. The private astronaut mission to the space station launches, and that's kind of cool for regular folks because, well, I know in 2021 we did a nice summary show right at the end of the last year, which we had 24 just regular people that got to go up, and maybe some of them got to orbit the Earth, including like William Shatner and Alan Shepard's daughter, and of course the folks from Inspiration 4. That was incredible. And now we've got this private mission. I don't know exactly how they pick, but Axiom Space is doing that. And again, Venus, I wrote down here mid-month, Venus will be the brightest at negative 4.9.
That's right.
Yeah, and it's early morning before sunrise.
That sounds great.
So those are the biggies for this month.
Dave, what are you most excited about in the next month or so?
We've got, well, not in the next month, but we've got 2 lunar eclipses this year that are both visible in North America. That's kind of cool. I just found out too, that second one in October, I think it's October or November, it's actually going to occult the planet Uranus while the moon is in eclipse, which is very rare. It's that to have any planet get occulted. I think it's
during an eclipse.
During a lunar eclipse.
Yeah, that's amazing. Yeah.
I'll talk about that later.
I think that's only like there's
add that to your list, Pam.
Oh yeah.
There's only like 10 such events in this millennium. Actually, where
fantastic.
The moon is a
Dave.
planet during eclipse. Yeah, that's kind of rare. Right, I just found out about that a week or so ago.
Oh, cool.
All right, thanks, Pam. All right, Ashley, let's talk about Jupiter. Mystery solved. Which mystery? Solved how?
All right. So the cyclones, the very large cyclones. Postdoc, Dr. Siegelman, she was looking at some of the cyclones on Jupiter in the where the polar regions where they evolve, and they were studying them because they were looking at them. They were just like, okay, maybe they're different from what we have here at home, but with some really cool tools, thanks to the atmospheric friends here that work on Earth, they're able to find that actually they're very, very similar, and that they evolve quite similar to how cyclones do here on Earth. And also they were able to look at them via infrared through some really thin clouds. So if it was like a day that was like really like thick clouds, they couldn't see it. But if they looked through the thinner clouds, so very like really, 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 really thin clouds, they're able to pierce through and look at how the cyclones were evolving throughout the duration of time. And so they said this will help them in the future understand more about cyclones and also their weather and other atmospheric sciences that is going on Jupiter.
So what, I guess, is the underlying mechanism that makes these cyclones get going?
So it's mainly when they're looking at the hot air transport with the energy and with the atmosphere, and so it's making these on the clouds, and it's evolving into larger cyclones, and so that's what's making it like so enormous and larger than here, and like obviously helping them understand why is it going on for so long, and so on and so forth. So
right.
Exciting work.
Yeah, and I think we'd seen that, from my understanding is that these structures are actually very similar to the way the ocean works. That the
yes,
yeah,
and that's something that I just really found really, really cool.
So like the atmosphere of the Earth. Yeah, the atmosphere on Earth is not a great analog for the cyclonic nature on Jupiter, but in fact, the ocean, because it's so thick and because it has sort of these temperature gradients that are going on in the ocean, that the kinds of structures that you get in the ocean are similar. So, and it was like, oceanographers or something that actually got to the bottom of this. Like,
right, which made it like such a great model, and that's why they were asking people like, you know, the oceanographers here on Earth and the atmospheric folks here on Earth, like, yo, can you get, basically it was like, yo, can you help me with this? That's basically what they said.
That's interesting.
I love it when they cross over the disciplines like that. It's important. And
yeah, because now it's helping them understand a little bit more about like what's going to happen in the future. And so this study was actually published in Nature Physics.
Oh, someone's got to log into their D&D account. All right, very cool. All right, we got just a little bit of time left. Dave, let us know about an interstellar spacecraft.
Yeah, this came out of the AGU meeting, the American Geophysical Union meeting at the end of 2021 or in December. And this is something that's been around for decades to do, and it seems like it's actually going to come to fruition. They want to propose, this is through Johns Hopkins University Applied Physics Lab. They want to propose an interstellar spacecraft to go, this is a Pioneer or Voyager style spacecraft that's going to be sent out of the solar system at extremely high speed with the idea to steady the heliosheath, the termination shock, the interstellar medium, all those areas that the Voyager spacecraft, like Voyager 2 is still operating, New Horizons is heading that way. They're all leaving the solar system on these trajectories out. But this mission would, unlike the Voyagers, don't really have this is kind of an extended mission for them, for Voyagers and New Horizons. The interstellar probe would be designed explicitly to study the interstellar medium. And there's a 500-page proposal paper out there because the decadal survey for solar heliophysics comes up next year. They want to propose this for launching in the 2030s to 2040 timeframe.
Right. And
it's really fascinating to me when you look at how much science they could do on a mission like this for studying, like I said, the interstellar medium, for studying what they call the astrosphere that we live in, and how much, like, you know, how much cosmic ray flux varies coming in, and how much the bubble around our solar system is protected, where our position is in the local bubble in the galaxy, you know, that we're currently transiting, like any signs of like ancient supernova explosions and things. It's amazing to me how much they could do getting out there. But this would have to launch extremely fast, faster than New Horizons, something like 70,000 miles per hour just leaving the Earth system to get out to the
as big as the Voyagers.
Yeah, this is going to go faster. This is actually
how about the size of it? Is it going to be?
It's going to be larger. They want to have two RTGs on the spacecraft, which Voyager only had one each.
Right.
And they wanted to do, and I don't think, talking to the researchers, are going to do this, what was called an Oberth maneuver, which would be the first time for a spacecraft to actually do a dive past the sun very close to send it flinging out of the solar system. But however, looking at, they would have to add a heat shield, that would add bulk, that would add complexity. It sounds like they want to do either a powered or a passive gravity assist past Jupiter instead of, at this point, to launch in the 2030s.
There's an interesting gravity assist opportunity coming up in 29.
Yeah.
And someone's proposed sending a mission out to Sedna, because sort of same thing that you want to do. You want a really good boost. And so you could do...
When you read the paper, there's 11 different potential KBO objects. It only makes sense if you're going that way anyway to go past something. You know, because this would be a once in a century opportunity. I think Sedna was on there. Quaoar, I think I'm saying that right. It's another one that they would really be interested to go past. There's 11 different targets in the paper that they were talking about that they could. So they could do that kind of science. They could also do, like I said, studying the interstellar medium. There's some interesting astrophysics they could do out there.
It's important to, I think the name is a bit of a misnomer. I mean, they're calling it an interstellar probe because they're going to go to the interstellar medium.
It sounds like it's going to another star.
To another star, yeah, and it is not.
Interstellar.
Yeah. I don't know what you would call that. Larry Beckham is asking, what would it take to verify that the Oort cloud is real? Way farther.
Well, you know, this is going. They have ideas to keep this going out to 1,000 AU over the span of they were talking 50 years out to 300 AU, in maybe over 150 years. This is relying on the ideas that the Deep Space Network is going to be upgraded, Goldstone is going to be upgraded,
Right.
those things, because the data rate, even like New Horizons, you see these prehistoric 2 KB per second data rates that they're getting back from. That's why New Horizons took like months to send photos back just from after it flew past Pluto. The data rates go way down. So this is relying on, if you're out at 1,000 AU, that there would be some kind of newer deep space network upgrade that would be able to handle something that faint.
Wow.
Yeah. I mean, it's pretty exciting, and actually getting out to that 1,000 AU range gets you in the ability to start using the sun as a gravitational lens, so it could test out that idea. Yeah,
I don't think they're going to do anything like that on this mission. Although you could, I thought, reading through the paper, I didn't see anything to that effect. I thought
at the very least, turn back and take a look.
China
but
has
it probably won't even have a camera on board. I mean, it depends where they're going to go.
That's going to dictate what they do for what sorts of flybys. If they go by something like Quaoar or Sedna, they probably will have some kind of camera on board. That kind of mission profile is going to dictate what goes on.
Yeah.
China wants to do, and they may launch in 2024. They want to do an Interstellar Express, a similar kind of mission.
Yeah.
So,
well, we've reached the end of our hour. So, Ashley, what are you working on, and where can people find out more?
Yep.
Yeah, you're good. Perfect. Yeah. Perfect. Dave.
Frequent contributor, Universe Today, Sky and Telescope, Bionis Telescopes, Astrogear Today, and I should have finally this huge article I'm doing on said interstellar probe done tomorrow for Sky and Telescope. It's a fascinating. The more you read, it's like, I hope I live to see the entire mission. I'll at least launch 2040s. I'll be 70 something by then.
Yeah. Pam.
So the most exciting thing that Everyday Spacer is doing is we're broadcasting live from every Friday night at 9 p.m. Pacific time from both the Everyday Spacer YouTube channel and the Everyday Spacer Facebook pages. And we have Amateur Astronomer Association coming up on the 14th. That's an astronomy club in New York. They've been involved in action since 1927. On the 21st, we've got Josh Carlson coming back. He's the author of Space Power Ascendant, and he's talking about the second space race that's currently ongoing between the U.S. and the China-Russia collaboration. And we invite you to share our live too. We have options for being a guest, and twice a year we're going to have an open mic night now.
Awesome.
Yeah.
All right. Of course, come to Universe Today. Sign up to my newsletter. We got lots and lots and lots of amazing news that we're putting out every day, all day long. So
cool.
Check out Universe Today. All right. So thank you, everyone, for joining us this week. Thanks to all my co-hosts for joining me. Thank you to our special guests. That was awesome. Thanks to everyone watching us on YouTube and on Twitch. Thanks to Pamela for engineering this episode. And thanks to Nancy for herding all the cats. Herding, not hurting, herding. Right. And we will see all of you and some combination of my co-hosts in the future. Thanks, everyone.
Good night.